Hi guys, welcome back to my channel, and today we'll be talking about another question called binary search tree insertion. So basically we'll be inserting a node in a BST. Now for those of you who don't know what a BST is, it is more like a tree, sorted binary tree, and these are the two most important points in a BST. That is, every child on the left of the parent node is going to be lesser than it, and every child on the right of the parent node is going to be greater than it. So here's an example. So this is the example that is given in the question. So suppose this is the BST given to us, and the value to be inserted is given as 6. So when you look at the tree, the first thing that you see is the parent node equal to 4. So 6 being greater than 4 will obviously lie on the right side of it. Proceeding, we see 7 as the parent node, and 7 being greater than 6, we should be inserting 6 on the left side of 7. It should be the left child of 7. So I hope this was clear, the way the insertion should take place. So let's now look at the code. So here we have our insert function. So as we know, if the root is null, then we will not just simply return, we will make a new node initialized with the data given by the user. So if there is no tree and the root is null, so we'll obviously have to make a new node and initialize it with the data and return that itself. But if that is not the case, that is, we have a proper tree, then we'll have to compare the two data. That is, if the data is less than the data present in root, and in this situation we will traverse the left side of the tree. So root left is equal to insert root left comma data. Now here recursion takes place, so we'll be discussing that using dry run. For now, it's important that you realize that insert, we're making use of the insert function, and then two parameters, that is root left comma data, and else, that is, if the data is greater than the data present in root, then we'll be traversing the right side of the tree. So that is root right is equal to insert root right comma data. So finally we return the actual root of the tree. So the most important thing that one should realize here is that there will be number of different values will be given to root in this step and in this step, but this is the if else condition, and the final this return root, here the root value will always be the same as that passed into the function, that is the one which is passed here. So this return root stands for that. And let us now look at the dry run. So initially our root equals 4. Since that is not equal to null, we'll simply move on to this if statement. Now here the data is greater than the root data, so we'll jump to the else statement. So root right is equal to insert root right comma data. So this means that the right child of 4 will now be passed as the root. So the right child of 4 from the diagram can be seen, and it is 7. So root equals 7 now, and since the data, that is 6, is lesser than 7, we can say root left is equal to insert root left comma data. So now the left child of 7 must be passed as the root into the function. But since 7 does not have either the left child or the right child, so in that case our root is null. So when the root is null, we have this if condition here. So the data is 6 and the root is null. So now we'll be forming a new node initialized with this data equal to 6, and then that node 6 will be returned. So return 6 justifies that, and then after that, so return means a return to the calling function. So here, so this is the calling function, and 6 will be inserted here. So that means root left, that is here, root is 7. So the left child of 7 will now be 6. So that is what was expected in the output. That is the left child of 7. As you can see here, left child of 7 is 6. And once this statement is completed, we will move on to the next one, that is return root. So from here, we'll be returning the actual root of the BST. So I hope this was clear, and let's now code the solution. So let's now code the solution for this problem. So if the root is null, we will make a new node. So new node, and then initialize it with the data that we'll be receiving. Then finally return root. Okay, so if block should be having brackets. Now if the root is not equal to null, so we'll have to compare. So if data is lesser than root data, then root left is equal to insert root left comma data. And if that is not the case, that is root data is lesser than. So root right, okay, yeah. Root right is equal to insert root right comma data. And once this if else condition is done, return root. So let's now run this code. Great. So this is what we discussed. This is the sample test case that we discussed, and I hope this was clear. So let's now submit the code. So great. I hope you liked this video. Thank you so much for watching.